Hello everyone, welcome to my channel Learning from Data. Today I'm going to talk about outliers. Well, outliers. It is a buzzword in the industry. Everyone wants to get rid of outliers. When the outliers are removed from the dataset, life becomes easier. In this tutorial video, I am going to talk about what is an outlier and how to identify these outliers by box plot method, and finally how to implement these in Python. So let's move on. Outliers are usually extreme data points that do not fit in the regular population. It depends on the definition of the outlier. Sometimes outliers are defined as data points that are above mean plus 3 sigma or below mean minus 3 sigma. If any value that is higher than mean plus 3 sigma value, it can be considered as an outlier. And on the lower side, if the data point is below mean minus 3 sigma, that can also be considered as an outlier. Here on the left side, we have a sample dataset. It is showing the scatter plot of two of the variables. It doesn't have any extreme high value or any extreme low value. Therefore, we can say that it doesn't have any outlier. On the right side, we have the same data points, but we have added an extreme high value over here. When this extreme high value or the outlier is added, it changes the linear function of all the data points. It seems like on the left side, the slope of this line is smaller than the slope of this line on the right side. Also, it will change the intercept from the previous data. So only one data point has extreme potential to change the whole model. That's why outliers are very important. Box plots are very handy to identify outliers. It has several parts. As shown here at the top, it has a minimum value. It also has a maximum value. Anything below the minimum value or anything above the maximum value can be considered as an outlier. It has some other parts also. For example, here Q1 defined as lower quartile, Q2 which is median, and Q3 defined as the upper quartile. The median value is the data point above which 50% of the data points lie here, and the remaining 50% of the data lie here. For Q1, 75% of the data is above this value and 25% of the data is below this value. For Q3, only 25% of the data is above that value and 75% of the data is below Q3. The line between Q3 and the max, this area is called the whisker area, and also here between the minimum value and the Q1, also called the whisker area. Let's do some math. Statistically, Q1 is defined as mean minus 0.675 times standard deviation, and Q3 is defined as mean plus 0.675 times standard deviation. If we subtract Q1 from Q3, we'll get 1.35 times standard deviation. Sometimes this standard deviation is defined as robust sigma or robust standard deviation. The way to get this robust standard deviation is just to calculate Q3 and Q1, get the difference, and divide that value by 1.35. In this way, we get a robust standard deviation. Down here, how the max and means are calculated are shown. The upper limit, which is this max value, is defined like Q3 plus 1.5 times Q3 minus Q1. If we put the values of Q3 and Q1 from here, we get mean plus 2.7 times standard deviation. In a similar fashion, if we put the values of Q3 and Q1 in the lower limit equation, we get mean minus 2.7 times standard deviation. Therefore, if we have this multiplier 1.5 times Q3 minus Q1, by the way, this Q3 minus Q1 is also called IQR, that is interquartile range. So if the multiplier of this interquartile range is 1.5, we get the upper limit as mean plus 2.7 times standard deviation and lower limit as mean minus 2.7 times standard deviation. Sometimes the practice is to make it 3, this value. Therefore, anything above mean plus 3 sigma or anything below mean minus 3 sigma can be considered as an outlier. To make this one 3, the multiplier should be 1.7, not 1.5 over here. Therefore, we can define the outliers according to our needs. We can put as 2.7 or you can put 3 as the multiplier of the IQR over here. I will go through a sample dataset to identify outliers using box plots. This is a sample Jupyter notebook. First of all, I imported all the necessary libraries. The sample dataset is inside this CSV file, the listings.csv. Let's read this one. Let's see the first 5 rows. It has the listing ID, listing URL, and a whole bunch of other informations. We will take the price column from this dataset and plot against the property type and see if there is any outlier or not. If we run this price, we see that it has a dollar sign over here, so I have declared a function to remove that dollar sign. Let's run this one, price, and let's use Seaborn to plot the price against the property types from our sample dataset. Let's run this one, and you can see the box plots for price according to several property types. You can see that this is a box plot, the minimum limit, this is the medium portion, and this is the maximum limit, and some of the data points are above this max value. This is also true for the apartments and maybe some townhouse condominiums. A lot of those box plots have outliers and values above the max. So you can see that when we use this box plot, it is very easy to identify these outliers. These are extreme values which don't fit in the regular population over here. Some of those box plots are very clean. For example, this one in the middle and this one over here, it doesn't have any outlier. It doesn't have anything on the upper side, also nothing on the lower side. It's very clean. If we remove the outlier using the quartile method that I showed you earlier, for example, we can use 2.7 sigma. That means anything above mean plus 2.7 sigma can be considered as an outlier, or anything above mean minus 2.7 sigma can be considered as an outlier. To implement that one, we need to get the IQR multiplier set at 1.5. As I mentioned earlier, if we want to make it 3 sigma, we need to make it 1.7 instead of 1.5. Let's implement this one with 1.5. If we run this one, let's make the figure size a little bit bigger. Okay. Once this one is implemented, we can still see there are a bunch of outliers over there, but it has improved a lot. For example, our second box plot, which is apartment, this one is the apartment over here. This has a bunch of extreme values over here. Most of them are removed when we implement this outlier removal method with IQR multiplier of 1.5. We have a few outliers still here in the house category, but some majority of the others are converted to clean data. Yes, this is the way you can identify outliers and remove those outliers from your dataset and make your dataset look cleaner, and which will make the analysis of the data easier. Most importantly, sometimes the removal of the outlier makes the data act like a normal. If the dataset is normal, you can do many of the statistical analysis very easily, assuming that the data is normal. I have a Medium article written on this outlier detection method and implementation in Python. I have discussed about 3 methods here in this article. The first one is IQR method that I have just shown you. The second one is the Hample method, and the third one is the dbscan method. We're going to talk about this one in the later videos. But IQR is very handy when we want to see the outliers in box plots. Here I have discussed how the interquartile range is calculated and how the multiplier of IQR is taken as 1.5. This is a sample box plot with several parts defined, and down here the IQR method is implemented in Python. I will provide the link to my GitHub for this Jupyter notebook. You can always open it in GitHub, or you can open it in Binder to run it live and see the potential outliers, and you can play around with multipliers over here and see what's the net effect of the multipliers to identify those outliers. Well, that's it for today. See you in the next video.